I kind of, especially for the kids in the audience, I kind of want to give a little bit of my background. Is that, so I was born not too far from here in Shamokin, Cole Township, Pennsylvania. And I started just as a space geek. I was really interested in Star Wars and Star Trek. You can see my Millennium Falcon from Santa Claus there, which I was real pumped about. And my X-Wing, I was really always interested in space exploration. I used to kind of, go to places like the Smithsonian, like science museums, festivals like this, kind of to keep that energy, keep that curiosity peaked of what's going on in space. So that really kind of is what got the fire burning for my for what I do now. I was a counselor at Space Camp and eventually went to Purdue and even played video games about the space station before it was even assembled, which was really kind of neat because the game really kind of encompasses a little bit about what I ended up doing. So that was kind of fun. So video games aren't so bad, right? They're pretty cool. And then eventually I worked down mission control down at NASA Johnson Space Center in Houston, Texas before coming to my current job at NASA headquarters. So the whole point of that was just kind of say, like, trust me, I was nothing special. I had to work hard for the grades that I got. I got, my tail handed to me pretty early in college with realizing how difficult it was, how hard it was to kind of get through some of those engineering courses. But I kind of had a resilience to fight through it. I wanted to work for NASA and I wasn't going to let that dream go. So sometimes things get hard, classes get hard, home life gets hard, school when things get hard. Keep fighting through that. Keep fighting through that because it's really cool once you get to the point where you get over those obstacles and kind of can fulfill and do your dream job. It's pretty special. So, all right. So here to talk a little bit about the International Space Station. And a lot of different goals on the space station. Here's some of them here. Primarily conduct research to benefit humanity. A lot of folks, it's really important to realize that the research being done on the International Space Station benefits life here on Earth. A lot of the science they do, both the medical field, physiological, the materials, a lot of this stuff benefits life right here on Earth. There's a lot of research that not just benefits exploration, but things that we can apply to our everyday lives here on Earth. And that's really important because sometimes, we'll hear like, oh, why are we doing all these things, spending this money on space exploration research when we can be fixing things here on Earth? And so that's why I really want to emphasize how important it is that we find different ways to do that research so we can benefit life on Earth. Things like osteoporosis, there's bone density loss in microgravity. So by understanding that better in space and what the astronauts can do to mitigate that, it'll help life on Earth. Macular degeneration, so eye loss. The eye changes shape in space a little bit. So by understanding how that works, it helps us kind of understand how we can mitigate that, again, to help life on Earth. Material structures, a lot of different things. So that's really important. Fostering a commercial space industry, right? A lot of the companies you see now that are very successful in helping contribute to our space exploration mission are contractors that won these contracts to do things for the space station, like take up cargo, like take up people and bring people back, and a lot of the different variables that make the space station work. The space station enabled that. We have this facility that enabled that opportunity for these companies to go fulfill that function, but then invest the money that they may make from that contract in themselves to improve themselves, to make their company bigger, stronger, for not just them as a business, but really us as humanity. So again, it's fostering a deeper mission than just cool stuff going up in microgravity. International collaboration, right? That's tricky. It's tricky when you can get people not just from a small group here or a small group in the United States, but groups around the world to go and work together, right? So the International Space Station is 15 countries participating in it, and it's really cool that we can have such collaboration like that. And the other ones, enabling deep space exploration and inspiring humankind. Those are also very important, right? Having things like I see a lot of kids in here, which is really awesome, right? The space station, by seeing the astronauts up there, seeing what they're doing, how they're doing it, I mean, that's cool to watch. That's cool to see, and that inspires. Kind of like I started with the last slide, that's what kind of fueled me watching the space shuttle missions and things like that. So hopefully, by watching what the astronauts are doing on the International Space Station, a lot of you young kids out there see that and say, hey, this is something I can do. And you know what? It's not too far from now that you'll be going into high school and college, getting that degree, and going and doing great things. That's really not that far away. So hopefully I'll be working with some of you in the near future. But, all right. So space station, kind of like I talked about, it's a lab like that. We have laboratories on Earth, but unlike Earth, right? Because it's in a microgravity environment. So you could see here, I kind of touched on some of these, the different types of research that we're doing. Human research, biology and biotechnology, Earth and space observation. We had the terrible storm here this past week. International Space Station was able to get some imagery of that, as well as some of the other space assets. Technology demonstrations, things that we're testing out that we're not sure how they're going to work or if it's a good idea or something that's really going to take off. We're able to demonstrate some of those technologies in a microgravity environment like the space station. So it's really kind of neat. So far, we've had more than 5,300 researchers in 116 countries and areas to do more than 4,000 experiments in microgravity on the International Space Station. So that's pretty amazing to think about all the, of all those experiments, all that research, how that's going to come to benefit humanity. Oh, I should have asked this question before I showed the slide, but now it's a softball question. Can anybody tell me how big the space station is? Go ahead. Yes, young lady in the middle.
About as long as a football.
Right, great job. That's my daughter. She's heard this a couple times. All right. So yeah, space station's about the size of a football field. So it's really kind of amazing when you think about if you ever go to an Eagles game or you go to your local high school or college football teams, and you can take a look at that football field and think, wow, that's how big this research laboratory is, this place where the astronauts live, work, play. It's really that big. Each of those solar arrays, you see there's 8 solar panels there. Each of those solar panels is about the size of a basketball court. So it kind of gives you an idea of how big this is, because sometimes when we think of space, we think back to the earlier days, where they're in the small capsules and they're just cramped in there in the seat, right? And then we got a little bit bigger. Then space shuttle was a little bit bigger. Like, okay, right? Now they got a little bit more room to move around. The space station is quite large. You can see about 356 feet wide, 240 feet deep, and about 45 feet high. So it's pretty impressive, the size of it. There's some other quick facts about the space station. We've had over 280 different people on board the International Space Station from 23 different countries. So that's pretty amazing when you think about that. The volume of it, kind of like I was saying, is about 36,000 cubic feet, and the habitable volume is approximately 13,000 cubic feet. So that's about that of the volume there is about that of a 6-bedroom house. And as you can see there, it's got 2 bathrooms, a gym, 6 sleeping quarters, and a really awesome cupola window that the astronauts can look outside and take pictures and whatnot. It orbits the Earth at, oh man, I gave that away too. How fast do you think the space station orbits the Earth? What do you think?
3,000.
3,000?
Yeah.
I'm sure it's 3,000 something. That's really close. How many miles, let me ask you this, how many miles per hour do you think?
13.
Ooh, pretty close. About 17,500 miles per hour. So a little bit over the speed limit here on Earth, right? That's 5 miles per second. So every second that we're going by here, the space station has moved 5 miles. So that's pretty amazing. So it orbits the Earth about 16 times a day. So about every 90 minutes, the space station orbits the Earth. So that's pretty cool. The neat thing about that too is, has anybody seen the space station fly over? All right, we see about half you. Great, that's awesome. We have a new app now, a Spot the Station app, and also the website I'll talk about at the end. But it's really cool if you haven't had the opportunity to see the International Space Station. It's pretty cool. It's impressive too. While you see that bright object in the sky, thinking that, wow, there's 7 people there living on that, working, playing. It's really impressive when you kind of put that in perspective. But I touched on some of the investigations in 15 countries. Space station was built, first element went up in 1998, And we considered assembly complete in 2011, but really we've been kind of building, kind of like our homes. Your home may be complete, but you add a shed, or maybe you might add a little bit to your porch, right? Or maybe you might expand on a room. That's kind of what we're doing with the space station. While we had assembly complete in 2011, we've added modules like the Bigelow Expandable Activity Module, which came up kind of compressed. And then once they got on board, they expanded it, kind of like a camping tent where you put it out, you expand it, and you put the truss structures out there to kind of help support it. And this module turned out to be, it started as a technology demonstration. Like, hey, can something that comes up, it's kind of like a Kevlar material. It comes up smaller and lighter in a smaller footprint, which means it's easier to get to launch into orbit and cheaper. But it's actually strong, very strong. Actually, I think it's stronger technically than some of the modules that are up there. So it worked out so well that we decided to purchase it and keep it up there for storage. So that's just one example of a technology demonstration that worked out and that could be used for future commercial space stations. All right. And did you know, it seems like, at least at the International Space Station, do you think we launched this over all at once or over time? What do you think? What do you think? Over time, right? Because it would be massive, right? Size of a football field, right? That'd be pretty hard to get up into orbit all at once. So we had to build it piece by piece. So the first piece went up in 1998, right? And then over the years, we added pieces through space shuttle missions or through some of our international partners, helped to build the space station. I seem to think it's like the world's largest Lego project, right? Who here, raise your hand if you've done Legos, right? Yeah, about like most of us here have done those, right? That's kind of what it was, but in about a massive scale. So it's really kind of cool to see how we did this piece by piece. And it was difficult, having worked in mission control during the space station assembly. I remember at the beginning kind of thinking like, wow, how are we going to do this? Everything's got to be just right, right? The solar panels got to fold out just right. The modules have to connect just right. I can't even get my doors in my house to close sometimes the right way, or the window blinds to go down without getting messed up. And then somehow we did this amazing structure. And it was really because of fine engineering, attention to detail, all those things. So we put it piece by piece together, and that's pretty impressive. I think future space stations are going to be similar, probably not this large of a scale, but you can see there all the different pieces from the 5 space agencies that we show there at the top. So it's pretty amazing when you think of how much had to go right for this thing to work. And now we're in our, what year now? 26th this year of the space station. It's pretty cool. So now I'm going to talk. So now I talked a little bit about what the spacecraft is. Now I'll talk a little bit about who's up there, right? So, because as in most organizations, right, the most important part is the people, right? You can build the structures, and that takes some fine engineering. That's very important. But it's people who do that. It's people who operate it, right? There's people who coach teams and do that and manage and lead people. So the people are really important. So for us, that's our astronauts. So right now, it's kind of an interesting time frame because we're in the middle of a crew exchange period. So about every 6 months or so, we send a new crew up and bring a crew back. So right now, we're kind of in the handover period. They go up and they have a little bit of a handover from one crew to another. That gives them time to kind of talk about lessons learned, show them around a bit, talk through some of the training and emergency processes. Then the other crew returns. So tomorrow morning, if the weather holds up down in Florida, tomorrow morning at around 7 o'clock Eastern, 4 of those crew members are going to come back home as part of the Crew 8 mission. So typically there are 7 astronauts on board. 4 come up in a Crew Dragon or Boeing Starliner, and then 3 come up in the Soyuz spacecraft. So that's why we typically have 7. But right now, because we're in crew exchange, we have 11 astronauts. What's kind of neat about this, too, it shows, I put the patches in there of the different spacecrafts that they came up in. So the Crew 8 mission, which is in that top left, they brought 4 astronauts up. Those are the astronauts that are coming home tomorrow morning. And then 3 in the top right, 3 came up somewhat recently on the Soyuz spacecraft. Those 3 astronauts are in the top right there in their red shirts. Then 2 of the astronauts in the bottom left and bottom right, Butch and Sunny, they came up on the Starliner mission in the summer. And then 2 astronauts came up on the Crew 9 mission a couple weeks ago, and they're going to return with 4 astronauts, including Butch and Sunny, next spring. So it's kind of cool to think like, wow, we're going to have crew up there that got up there with 4 different spacecraft. So that's pretty unique, actually. So kind of show this. This is a little bit, this is one of the upcoming crew schedules. While they're up there, they're doing a lot of amazing stuff. Right? Obviously, they're doing research. But what else do you think is in their timeline? Anybody have an idea of what might be, what else the crew is doing up there? Yes? Yeah, yep, they've got lunch breaks. You can kind of see on some of that, the midday meal in there. All my answers are up there, right? What else? What do you think? Yeah, they get exercise. So remember, I talked about microgravity changing how our body works a little bit. In order to kind of counter the impacts of microgravity on muscle atrophy, bone density loss, things like that, they exercise for 2.5 hours a day. So the crew members, they have a treadmill up there, which is, where do you think the treadmill is? Where? What's that? Yep, it's actually in one of the modules, but where is it on the floor, the ceiling? It's actually on the wall. Good answer. Yeah, you got it. The treadmill's on the wall, right? They have a harness that they use to kind of keep them to it, but they actually run the treadmill, and it operates just like really a treadmill on Earth pretty much. So it's pretty amazing. One of the astronauts even ran a marathon while the marathon was happening on Earth. She ran it on the International Space Station. And at 5 miles a second, she probably would have won, right? So that's pretty cool to have that. They also have a resistive exercise device, so a device they could do like pull up and do like squats or push-ups or curls, right? And they also have a exercise bike. So they have different types of exercise equipment they can use to kind of keep their bodies. And now it's really kind of impressive, because now when these astronauts come back home, even after 6 months or longer on the space station, a lot of them are really capable of just getting up and walking out of the spacecraft. Sometimes we conservative, we might put them in a chair or roll them over to their next place to get checked out in something like that. But a lot of times they'll walk right out of the capsule, which is pretty cool. And I think that's an attribute to the amount of research we've done over decades of human spaceflight activities to be able to monitor how we can help improve getting back to normal on Earth after long microgravity missions. So this kind of shows a little bit, shows each of the 7 crew members. It has their meals, it has their exercise plan. They also do some logistics. So on the space station, it's pretty massive and it's pretty complex and takes a lot to keep it going. And just like in our homes or our cars, things sometimes need to be replaced. We might need to, they got to clean the filters on the weekends. A lot of times they'll go and they'll clean the filters, because you can imagine sometimes when you're working or you're eating or you're working on something, right, things tend to float away. We try to minimize that, right, but it happens. So sometimes on the weekends they'll go and they'll clean out the filters, and sometimes they're like, oh, there's that wrench. Or, oh, peanut M&M, what's that doing there? I know we'd never find peanut M&Ms missing if I was up there. I'm just saying, don't worry about that. But so they're doing logistics things, sometimes replacing, repairing. Also, too, they have research, of course. They do a lot of research during the day. And then, of course, sometimes it's training. Some things you see up there is OBT, that's onboard training. So when we have a new crew up there, or if there's a new process, the crew will get together like, all right, here's what happens if we have an emergency and this type of emergency, here's what we do. You 3 go there, you 4 go here, you do this, I'll do that. And they go through those so that, just like anything, if you ever have an emergency, preparation is key, right? The more you can prepare for something, the easier it is to take care of it. And that's really important. So they do onboard training, and then sometimes at the beginning and at the end of every day, they have a daily planning conference. Well, they'll get together at the beginning of the day, and the mission control team on the ground will call up, like, hey, everybody, good morning. Here's what you got on the plate today. Sonny and Butch, you'll be doing this. Matt, you'll be doing that. Nick, we've got this for you. So it's really kind of cool to be able to have that. All right, here's what we got going on. Here's things to watch out for. Here's things to report back. And at the end of the day, they do something similar. Well, they'll get on there, talk to the crew all at once. All right, great job, everybody. We learned a lot from this. Don't forget tomorrow we've got the undocking. So here's going to be your schedule for that. So it's kind of nice they have that. And then sometimes they'll have, you see at the end of the day, this pre-sleep Pre-sleep is kind of everything we do from when we get home till we go to bed. Sometimes it's catching up on some tasks. Sometimes it's talking to your family. Might be looking out the window. Sometimes floating around the corner, maybe just getting away from it all for a little bit and getting some me time over in their crew quarters. Sometimes going taking pictures, calling family. So they'll take those opportunities to do all those types of things, and of course eat dinner. And then they'll have sleep. They typically sleep, on a normal day they'll sleep about they'll go to bed around the same time, wake up around the same time. Sometimes that'll vary depending on the activity, but generally they try to do that at the same time. They actually operate off Greenwich Mean Time, so GMT. So it's a common, it's really important we have a common time zone to reference, so because we have these control centers all around the world, and the flight control teams, even in different time zones here. So by operating off GMT, that allows us to really be in sync and make sure we're all squared away. So they're about 4 hours ahead of us right now. So the crew right now is about 5 o'clock, so they're kind of wrapping up their day. Weekends are generally lighter. The crew has some downtime. We don't want to work them too hard, right? Because they do a lot of work. You can see this day, that's packed. So we really, really get a lot out of our astronauts on board. So we want to also kind of make sure that, hey, we don't want to work them too hard, because it's important in life and work to have a balance, right? It's really important to work hard. I encourage everybody to work hard, study hard, but also make sure you have a balance, and sometimes stop, smell the roses, look at the goldfish, enjoy life. That's really important. So some of the spacecraft that we take cargo and research to and from the space station are listed here. We have our international ones, such as the Progress from Roscosmos, the HTV from the Japanese Space Agency, the ATV from the European Space Agency, since retired, and then some of our commercial cargo spacecraft, like the Cygnus from Northrop Grumman, the Cargo Dragon from SpaceX, and soon we're going to have the Dream Chaser from Sierra. So what's kind of neat about this is, they could take a lot of research and cargo up. Some of them bring cargo back, or research back, like the Cargo Dragon and the Dream Chaser. But spacecraft like the Cygnus and Progress are also important because they take away stuff we don't need anymore. They take away the trash or the garbage and things like that. So it's really kind of important because otherwise, can you imagine if your garbage person didn't come for a couple weeks or a month or 2 months? What would that look like, right? We just have this excess of stuff we didn't need, not good. So it's really important we have the spacecraft to take things away as well. It's even more important that we kind of be sustainable without excess equipment and hardware, things that we can do. So for example, one thing I didn't talk about earlier, which I really enjoy talking about, is water, right? You know how heavy those water jugs are. Can you imagine if we had to just keep taking them up to space for the astronauts to drink? That's all we would take up. We'd spend all our money on just taking water up into space, right? But so what we do is actually, how do you think we handle that situation? Anybody know? Yes?
You recycle it.
That's right, we recycle it. So what we do is we take the moisture in the air, right, a little bit, right? And they take the urine from the astronauts, so the pee, right? That goes into the system, takes out the bad stuff, puts in some good stuff, and it comes out cleaner than bottled water we have here on Earth, right? And that way they can recycle that. And so over 90%, I think it's around 95 or 98% of the water used is actually recycled in space. So that's really important. And the cool thing about that technology too is hopefully at some point down the road we can kind of implement some of those measures here on Earth, especially in places that might not have the infrastructure that we're fortunate to have, but to be able to recycle, use recycled water for things like that. So that's really important. But the thing I really like about this too is, what's something that you notice, what's some things that you notice about this and all those different spacecraft? What do you think? Do they all look the same? No, they look different, don't they? What's something you find unique in one of those? What's something that looks different, maybe? What about the shape of the solar panels? They look different or the same? They look different, right? So what's kind of neat about this is they all look different. I think that's important, especially when talking with students, is that it's sometimes easy in life, and this is really probably for as much people my age and older too, really easy to get into a mode where we always do the same things all the time, right? Or do things like we've done it before. That's what we're used to, that's what we've done, but maybe that's what your big brother or big sister did. But it's really important to have diversity of all kinds, right? Technical, people, backgrounds. Diversity is very important so that we can understand things differently, see different perspectives, use different types. So here you can see the solar panels. One spacecraft has solar panels that fold out rectangularly. Another one has ones that fold out like a fan in circular shape. Some are wrapped around the spacecraft that way. Different ways of doing things to accomplish the same things. That's very, very important, is to think differently. We're doing a lot of things right now that at some point people said were absolutely crazy. And I can tell you, me included, I looked at some things that are being done now and how we land some of these first stages and reuse them. When that first started, I'm like, boy, this is going to be really impressive if this works out. And the first couple exploded and failed, and they thought, like, this is hard. This is hard, but like, I'm here watching. I got my popcorn. I'm watching to see how this goes. And now it's become almost routine and so successful because, one, they thought differently. They heard the people say, you're crazy, not going to be able to do it. They said, okay, watch this, right? Hold my milk. I got this, right? So, and then they did it and they performed it. So they didn't let failure stop them. They thought differently, right? They were resilient, right? And they kept going, and now they've improved things to make things cheaper and easier, and that made space more accessible, right? So that's really important, to think differently, right? Don't just always do what Big Brother, Big Sister did. Think differently, and that's the best way we can grow. This kind of shows some of the habitable volume of the space station, the different modules. You can see the Crew 8 Dragon and the Crew 9 Dragon. Those were two of the sets of crew members are. And we have the Soyuz and Cygnus spacecrafts there. So this kind of shows what the space station looks like and all the things they do. All those modules, they have, the purposes of them are crew arrival and return. They bring up cargo. Some of the modules help provide attitude control propulsively, but my favorite part of the space station are the gyroscopes. You know what gyroscopes are? Those little spinning wheels. Do you ever see it at the science museums, things like that? They have those cool spinning wheels on a string. Sometimes you see them, right? How many do you think we have on the space station that we operate from? We actually only need 4, actually, and sometimes we can even get away with less than that, but we typically have 4 functioning gyroscopes on board the space station. They're about the size of a washing machine, and they're kind of, if you see where that Crew 8 Dragon is, if you go back a little bit on the Z1 Trust, behind that is where those 4 washing machine-sized gyroscopes are. And what's cool about them is that they allow us to control the International Space Station non-propulsively. So just by taking the power from the sun, that powers the gyroscopes, and by changing the angular momentum from those gyroscopes, it allows us to control the International Space Station non-propulsively. That means we don't have to use propellant, because like gas in cars, eventually it runs out, right, if you don't refill it. So if we had to always use propellant and thrusters, eventually we run out. So it's really cool that we can control the International Space Station, the size of a football field, right, non-propulsively, just basically free, right, and that's pretty cool. So Mission Control was able to do that, just a couple clicks of a mouse, and you're able to change the whole space station around. So that was kind of fun. And teamwork. I should do a time check, make sure I don't go too far over here, but just like anything big in life, what it takes to accomplish involves more than just one person, more than just one thought, more than just one idea. It takes a team. So this is a picture from Mission Control. So that was our Attitude, Determination, and Control Officer console on the top left there where I used to work. That's our baseball bat, which is our attitude control device. So we were able to, this was from the last space shuttle undocking many years ago. But here, what's kind of cool, why I show this picture is you have various different disciplines. Like our group in the top left there, we were the attitude control. But then we have the thermal group and the power group also in front, the communications and tracking officers. We had our flight director, who they're kind of like in charge of managing our team of flight controllers. We all had to work together. I couldn't go and just change the orientation of the space station without communicating and planning with the folks that manage the antennas. Because if an antenna is pointing it over there and I move the space station like this, now that antenna is pointing there, right? So that we need to make sure that we switch to that satellite. And we got to make sure that the power, we're tracking the sun with our solar arrays. So it's really important that we kind of work together as a team to make this work. And then there's many, many, many groups in mission control that do the planning. I showed you that timeline earlier. A lot of people work on that and the planning, work with our international partners. So it's really kind of important that we work together as a team. So I'll kind of go into that here, and I want to get to some questions, but kind of what the flight controllers do. We talked about the people in space, but what do the people on Earth do? And this is a lot of what some of you may do here, right? And this was what I started at right out of college, being a flight controller. We help develop the plans, procedures, and flight rules for the space station. All right, once we get certified, we go through a really intense training, really intense training. Have you ever been through like either a music practice or a sports practice, something like that? What kind of practice have you done?
I have done basketball practice.
Basketball practice, right? Was it easy or was it hard?
Hard.
It was hard, right? They make you run around, that kind of stuff. It's hard. Anybody else play an instrument or on a sports team? Yep. Yep. Good. What kind? Yep.
I
Play piano. Well, we know how much practice that takes, right? What about you?
soccer. I used to do soccer, but now I do basketball.
Awesome. So all these sports, right? It takes hard. You can't just walk out and expect to go and just shoot the ball or throw a baseball or play an instrument without practice and coordination. Well, that's what we had to do. We had to get trained to get certified to fly the space station so we could monitor and control it and make sure that the crew and the vehicle are safe. All right. And a lot of people think, well, I don't, that's really hard. I don't know if I could do this, or I'm not interested in this, or what does it take to get there? Oh, we have to go through all these engineering and science classes. And yeah, that's important. But some of the other skills these are the skills that they evaluate us. We're going through our flight controller training, mission control. Yes, the top one is technical knowledge. You have to know generally what's going on. So in sports or music, you got to know what the notes mean, all right? And when a note is here, that means this key, right? In sports, you got to know the rules. You got to know how to throw a baseball, how to shoot a basketball, right? Technical knowledge is important. But that's probably the easiest thing to acquire when you're doing something. These other ones, often people call them the soft skills. These are things that I feel are most important, right? Communication. You could be the smartest person in the room, smartest person in your class, right? But if you can't effectively communicate that with your teacher, with your peers, with your teammates, right, with the people that are asking you to do something, then that's not very effective, right? So it's very, very important to have good written and verbal communication skills, making eye contact, getting all that message out. So important to be a good communicator. Problem recognition and resolution, right? Understanding when you see a problem, for example, like a stormtrooper at the door, right? What is my process here? I don't know. I think we're okay. Remember, they don't have good aim. All right. So problem recognition and resolution, right? So also attitude, effort, and integrity is very important. It's very important to do things the right way, right? Isn't it important to do things the right way? Definitely important, right? It's very important to do that, to be truthful and honest and do things the right way. You'll never regret, even if it's harder, doing things the right way. And then leadership and teamwork, right? That's very important. It's very important to have those skills because doing big things is not easy. It's hard, and it's going to take resilience, and it's sometimes hard to get knocked down. I always like to use my Rocky quote, it's not how hard you hit, it's how hard you can get hit and keep moving forward, how much you can take and keep moving forward, right? That's how winning is done. That's how we do things as well. It's how much you can handle, how many things, how many problems you can solve, and keep going forward towards your goal. So those skills, kids, are very important. So you're training for that right now. Right now, first, second, third, fourth, sixth grade, freshmen, college seniors, right? You're learning all those skills right now so that when you get out in the real world and have a job and a profession, you've had experience in those skills. So that's really important. And then kind of the last couple things before I get to question is, a lot of what we're doing on the space station is helpful for future missions, like the Artemis missions to the moon. We're testing things with regards to spacesuits and human research and life support, so we can help we can help the Artemis missions go back to the moon and beyond. I talked a little bit about the benefits for humanity. I have some flyers down here, but also the QR code. All those amazing things I talked about, the benefits of life here on Earth that we do on Space Station are right there in that booklet. It's a really awesome online guide and physical handout. So it's really pretty impressive if you have a chance to check that out. And Space Station, so there you can check out the Spot the Station app. You'll get to see when the space station flies over. And also, here's some times for the Lehigh Valley area upcoming. Now, they're kind of early, so kids, if your parents like to sleep in, maybe, try to find one that's a little later, but he likes to sleep in. So those when you can see the space station flying over the Lehigh Valley over there. So that's pretty cool. I encourage you to check them out. And now for the fun part. I enjoy talking about the space station, but I enjoy answering people's questions even more. So does anyone have any questions? We'll start in the back.
So have you had to alter the space station's orbit at all for space debris?
Yeah, good question. Question was, have we had to alter the space station's orbit for space debris? The answer is yes. Fortunately, we don't have to do it as often as we used to, because now we have capability to kind of react later than we had in the past, which is good. We shortened the process to be able to get notified of a piece of debris that may be in the area, and then what it takes to respond. We have some templates that we put on board to help shorten that time frame. But yes, we have had a couple times a year maybe, we might get a piece of debris that looks like it might be too close to the space station for our comfort, so we've had to raise the altitude of the space station to get away from that debris. But it is something we take seriously. Space station can handle getting hit by really, really small things. So sometimes you can see maybe there's some chips on the handrail or something. So space station is designed to take a little bit of a hit, but certainly not some of the bigger ones. So yes, we have to do that, and it's monitored regularly. Good question. Yes?
How often do you guys have to use the thrusters on the station to push it up, and how long are the burns to make the station still stay in orbit?
Yeah, good question. So how often do we have to raise the orbit of the space station? So the space station, it's about 415 kilometers above the Earth, but it's really in microgravity, not zero gravity. Sometimes people say, oh, it's up in zero gravity, but it's actually, the space station is slowly coming back to Earth as we speak. So in time, it just keeps coming lower and lower. So about maybe once a month or so, we'll have to fire some thrusters to raise the altitude to keep it in that orbital regime that we want it. So maybe 10-ish times a year approximately, we'll have to raise that up. So yeah, so that's important too, right? Because we want to make sure, and then sometimes when we have visiting vehicles coming, we'll want to, we'll plan that accordingly so that it's at the right phasing for those visiting vehicles. Very good question.
How often are Cygnus spacecraft sent up? Is it still once yearly, or has it been sped up or slowed down?
Yeah, it's a couple times a year. We've got there, so I think this current year is 2 or 3. I can't remember exactly, but about that. That's very important. The Cygnus spacecraft's built not too far from here, down in Dulles, Virginia, a couple hours away. So yeah, several times a year. Good question. Yes?
I was wondering if you could get some of your crew to help me out with my first project on building a rocket.
So
I'm actually interested in building a rocket.
I think that's great. First of all, do you know these guys? You're sure? Do you know them over there?
Yeah, I actually did watch a couple movies of Star Wars.
All right, me too. Well, good. Well, I'm counting on you to help protect us, right? So yeah, we happy to help. Happy to help. It's great that you're working on these projects at such a small age, because hands-on learning, like building rockets and doing things like that, is so important to figuring things out. So I'd be happy to help you out in any way possible that I can. But learning's how you're doing. Don't be afraid to fail when you do things. All right.
Also, I have one last question.
Of course, go for it.
Ever since I
You think? Well, I'll tell you what, I bet you if you went to space or you work for NASA, we will take care of you as much as possible to try to make sure you don't get sick in space. I think you could do it.
He was wondering if there are, like if you get motion sick, if there are plenty of jobs you can do with NASA that wouldn't involve.
Absolutely. Tons and tons of jobs. So the question was, do you have to, some people are afraid of heights or they might get sick easily or they can't go to space for various reasons. Are there jobs at NASA? Absolutely, positively. There's tons of jobs, right? Because we have not just engineers, we have scientists, we have people who do graphic artists that do some of our technology. We have teachers, all right? We've got people who work the budget, people who help with our legislative affairs, international relations. Have a nice day. So yeah, there's tons of cool jobs you can do in all different fields, not just space, but like thermal or electrical. So absolutely, if you're interested in space, we've got a job for you, but you got to keep studying. All right, can you do that?
Yeah.
Promise?
Yeah.
All right, good deal. Yes.
I'll meet,
Go ahead. Sorry.
I'll meet back up with you what I've said, okay?
Okay, let's do this. All right.
Maybe when I'm sick, so I don't know.
We'll take you. We'll take you. Yes, sir.
So why is the ISS kept at the specific height of 415 or so kilometers?
Yeah, it changes. It's changed over the years a little bit, kind of based on the environment, the solar environment sometimes. But also it's good phasing for the rockets as well. So that's a lot of it. It's at an inclination now to where it's more accessible for all our international partners as well. But typically that's part of it. Find that sweet spot in our space environment. Yep. Yes.
Given all the different countries and companies, is cybersecurity a thing on the space station?
Yeah, of course. Definitely take, just like anywhere, we take that seriously. We have a network up there that obviously we want to make sure is protected. So just like here on Earth, cybersecurity is important up there. Just like the environment up there, the regular atmosphere environment within the spacecraft, you want to keep pristine. Same thing with the network. So IT jobs especially too, and in mission control. You have to have certain types of protection, encryption, both on Earth and in space. So that's very important, and it's getting more and more important as we go on and build on. So yes, sir, very much so. Yes.
Is there any times when you make the space station go lower because if you go too high, you'll hit the van down and melt?
So we typically keep it within a certain regime. In the 400, right now we're at the 415-ish kilometer range. We typically don't intentionally lower it, right? We'll typically raise it because naturally it's going to slowly deorbit over time. So we typically raise our altitude to keep it in that, keep it in that orbital regime that we want. But that's a very good question. And we do kind of factor in things like the environment, as I mentioned, to make sure that we are at the right altitude. Like we used to operate at a lower altitude, now we're a little bit higher. So that's definitely something that we regularly track. Yes?
What was the process of applying to NASA and working for NASA?
Yeah, great. One of the best places to get started is, well, the nasa.gov site has a lot of that for internships. I have some flyers down here too, talk about some of the NASA internships. There's a NASA jobs location as well, but the intern.nasa.gov is a cool place that kind of illustrates the different types of places to get started at NASA. But also realize too, there's not just NASA that works in that, but it's also a lot of the contractors. We work together as a team. Some people think we're in competition with some of these contractors, and it could be further from the truth. We actually work in tandem with them. We work really closely together with them. So there's NASA jobs with the federal government, but there's also jobs. I know I started out as a contractor, and then a lot of contractors all over the world, and certainly the United States, where you could get a job that has an important role in the space industry. And that's really important that we all work together. So, don't limit yourself. Really look at different places as well. But yeah, the intern.nasa.gov is a good place to start for things like that, for internships. Yes? Are there some foods that astronauts can't eat? Yeah, why? Yeah, because that's a good question. So astronauts' diet is somewhat regulated because you want to kind of when you're in an environment like that, right, where it's not super easy to just get out and go to the doctor or to do. You want to kind of limit the foods that might be kind of risky, right? So, or if there's something that maybe might make you go to the bathroom more, that's right. Maybe that's something you might not want to have while you're on space. And also, sometimes astronauts like to mix up the food to their different taste. Taste buds dull a little bit in space. So sometimes astronauts might like some spicier food just to kind of get a little bit more stimulation for the space or their taste buds. But yeah, their food is regulated. Not a whole lot. As a matter of fact, their food's a lot better than you think. They have a food science lab down at Johnson Space Center that does a great job of coming up with different foods. But also things like you don't want to have a lot of bread on the space station. What happens with bread? You get breadcrumbs. Breadcrumbs end up floating around. They could get in something. So a lot of times they use tortillas. So they'll make something with tortillas instead of bread. Another question. Yes, sir.
So now with the growth of AI, has NASA been looking into using it for like some of these heavy calculations you were mentioning, like elevation and all that stuff?
Yeah, NASA's embracing the AI movement. To what extent, it's hard for me to say right now, but definitely embracing like newer technologies. There are things up there to try to figure out how we can simplify or make some, say, remedial tasks maybe go towards, something that can track that without the astronaut doing it, so the astronaut could do more intensive hand-on research. So yes, I think NASA, like a lot of people, are embracing future efficiency options like that. I can't speak specifically to the AI and how they're doing it, but absolutely, certainly embracing things like that. And Marty, give me a time check give me a 2-minute warning.
Okay. You have a couple more minutes for a couple more questions.
Okay, all right. Yes.
What is the Wi-Fi like in space? Do they get it directly from the space station or from like neighboring satellites?
Yeah, so they actually have a pretty strong network on board. They could do things because the astronauts will have a lot of times their procedures on their iPads, things like that. They use kind of an IP phone for when they talk to their families, things like that. But they do have a strong network on board that they can communicate both internally and with the ground network. So it's obviously it has to be very strong and efficient because the crew needs to be able to operate. But we also have the TDRS satellites, Tracking Data Relay Satellite System, that we send commands from the ground. They go up to the TDRS, then down to the station, and then we get telemetry and the voice to and from the space station up to the TDRS back down to Earth. So we have a pretty strong network both on the ground and then internally with the space station. So very good question. Saw a question in the back.
Yeah, how classified are the experiments that like the astronauts are doing on the space station? Like, if they call their family and they complain about plants dying in the experiment, or is that like off limits?
So yeah, a lot of the research is done is really open. There may be some proprietary research done by a company that isn't necessarily quite yet broadcast to everybody, but a lot of the research that's done, and certainly a lot of that ones that NASA supports, is open for everyone to reap the benefits from. So I say a majority of that, and eventually probably most of it, and that might not be company proprietary, would be out, and that's why we have like this book that I mentioned about the benefits for humanity shows so much of that research that's out there. Every year or two or so, or 2 or 3 years, a book like this comes out that highlights those, and it's fascinating. So I encourage you to go check that out. But maybe one more question, and then we'll go. Did anybody get to one that didn't answer yet? But, all right. Oh, I'll get 2 more. Sorry. Go ahead.
My last question is, depending on the size of the burn you have to do and like how long you have to do it, do you like switch between like monopropellant fuel or like solid like liquid fuel on the International Space Station?
Yeah, so we use liquid propellant on the space station. So the thrusters thrusters in the back of the space station use unsymmetrical dimethyl hydrazine and MMH and UDMH, monomethyl hydrazine and unsymmetrical dimethyl hydrazine. Hopefully I got those right. But that's what we use on the thrusters on the space station right now. So we don't have any of the solid propellants there. Last question.
How long do spacewalks usually last?
Yeah, good question. How long do spacewalks usually last? Usually they're outside for, I don't know, between like 6 and 8 hours in that general time frame. Sometimes shorter, but usually that's kind of the length. But they have to prepare long before that as well to get ready. So like the process of doing a spacewalk starts much earlier, but typically they're outside for in between 6 and 8 hours. So these are great questions. I really appreciate everybody's attention and time and for coming to this. And thank you to the organizers of this event. It's a great event. I really hope that you come out and support things like this to help stimulate the excitement in STEM activities. So thank you very much.
Round of